This is Pre-Calculus Section 1.5 Notes, Day 3. We've been talking about quadratic equations. Today we are going to talk about applications of quadratic equations. The first thing we're going to look at is an initial velocity problem. This is a lot like something that you might encounter in a physics class. An object is thrown or fired straight upward at an initial velocity of v sub 0 feet per second, will reach a height of h feet after t seconds is represented by the equation. Okay, so first of all, let's think about this equation has ordered pairs that are of the form t, comma, h, right? So t is like x and h is like y. T stands for time in seconds. That was given in the problem. And h stands for height in feet. Always good to know what your variables represent. So we've got this object that's either being thrown or launched upward. So we're going to be talking about something that's going to make a parabolic shape, because obviously initially it's going to go up, but then it's going to reach its maximum height and then it's going to come back down. So it's going to make a shape like a parabola. The next example, suppose an arrow is shot upward at an initial speed of 80 feet per second. Determine each of the following. So we're using that equation that we were given in our previous problem, or in that initial problem here, but it tells us here that the initial speed is 80 feet per second. So that's our v sub 0. So the first thing we're going to do is we're going to plug that into the equation. So we're going to have 0. It says, when does it fall back to ground level? I put 0 because the height of the arrow is 0 when it's on the ground. So that's why we're going to be setting it equal to 0, or 0 equals. So it's going to be 0 equals negative 16 t squared plus 80t. We're going to be plugging in our v sub 0 of 80. Well, there's a GCF here. 16 goes into 80, and we can take a t out of both terms. Since our first term is negative, I like to make my GCF negative. So this is going to be negative 16t will be my GCF. And then this becomes t minus 5 when I factor out that negative 16t. So this is going to give me two answers. According to the zero product property, this monomial tells me that t equals 0, and this monomial tells me that t equals 5. Okay, now why do we have two answers? The question is, when does the arrow fall back to ground level? Well, remember, the arrow is actually on the ground 2 times in this parabola. It's at the ground at the start, and it's at the ground at the end. Okay, so t equals 0 represents the starting time, and t equals 5 represents the arrow at the end of the parabola after it's gone up and come back down. How high is the highest point that the arrow reaches? The highest point always happens at the vertex of the parabola, but specifically the height is the y value of the vertex. Okay. The x value of the vertex of the parabola can be found by the formula x equals the opposite of b over 2 times a. Maybe you remember that from Algebra 2. That's how you find the x coordinate of the vertex. Okay, so the highest point happens at the vertex. The height is the y value. The x value can be found by the opposite of b over 2a. All right, so if we want to solve this, we know that our a value is negative 16. And we know that our b value is 80. Those come straight from our equation above. So the x coordinate of our vertex, we have to find the x coordinate in order to find the y coordinate, because we need to plug x in to get y. So the x coordinate of our vertex is going to be the opposite of our b value, so negative 80 divided by 2 times our a value, so 2 times negative 16. So we have negative 80 over negative 32. Okay, which negative over negative reduces to positive. 80 divided by 32, if we grab a calculator, that's just 2.5. Okay, so this value shows us that it takes 2.5 seconds for the arrow to reach the highest point on the parabola. Now the height at that time, 2.5 seconds, we can find by plugging 2.5 in for t in our equation. So our height is going to be equal to negative 16 times 2.5 squared plus 80 times 2.5. And then you just grab your calculator and you type that in, and your calculator tells you that the maximum height that this arrow reaches is 100 feet. Okay. And I just wanted to add a little note right here. The time is the x value of the vertex. Okay. Now we're going to change gears a little bit, and we're going to talk about what we call quadratic type equations. So these are equations that have the same form as a quadratic equation, but they're not quadratic. However, we can use some of the tools in our toolbox that we already know to try to solve them by treating them like they are quadratic equations. So these may contain powers other than x squared, like maybe it's going to be x to the fourth or x to the sixth, who knows? We're mainly going to use factoring to solve these, or possibly we'll use the quadratic formula. All right, so our first example, we have x to the fourth minus 11x squared plus 18 equals 0. Some positives here. 3 terms, already set equal to 0. So this is what we would call a quadratic type. It looks like a quadratic equation. And it's similar to, if we just say, let's do a little substitution, okay? X to the fourth is really x squared squared, right? So let's do a little substitution, and let's just let w equal x squared, okay? So if we let w equal x squared, then this equation is similar to, or becomes, w squared minus 11w plus 18 equals 0. Okay, now that's something I can totally solve. It's easy. I can solve it by factoring. That's an easy factor. Two numbers that multiply to make a positive 18, but add to make 11, negative 11, are both negative, so that's going to end up factoring into w minus 2 times w minus 9 equals 0. So by the zero product property, that tells us that w equals 2 and w equals 9. Now we're not done with the problem, because remember we did a substitution. We let w represent x squared. So now we have to bring that back, and we have to say, well, that means that x squared equals 2, and that means that x squared equals 9. So if we solve by square rooting both sides, that tells us x equals plus or minus the square root of 2, and over here x equals plus or minus 3. So we actually have 4 solutions to this problem, which makes sense because we had an x to the fourth power in our equation. The highest exponent in our equation tells us how many total solutions we should expect to have. Last example. This one is a little bit tricky, but the first thing I noticed that we need to do, our first step here, is we have to set this equation equal to 0, because we've got 3 terms, but they're not all on the same side of the equal sign. So I am going to subtract that 10x to the negative 3 halves over to the other side. Okay. So now I have x to the 1/2 power plus 3 times x to the negative 1/2 power minus 10x to the negative 3 halves power equals 0. Once again, this is a quadratic type equation, okay? And there's actually a GCF here that we could take out. We could factor out an x to the negative 3 halves power from all 3 of our terms. This admittedly is tricky, okay? Takes practice to notice these things. But if we take out an x to the negative 3 halves, Keep in mind, when you multiply powers with the same base, you are adding exponents. So we just have to think backwards. Negative 3/2 plus what makes positive 1/2? Well, negative 3/2 plus 4/2 would make 1/2. So then this has to become x to the 4/2. Negative 3/2 plus what makes negative 1/2? Well, that would have to be 2/2. And then finally, if we factored out the x to the negative 3/2, this just becomes negative 10. Well, look at our exponents now inside the parentheses. 4/2, that's just x squared, and 2/2, that's just x to the first power. So we have x to the negative 3/2 as our GCF, and then inside the parentheses we have x squared plus 3x minus 10. So on this problem, we did not do a substitution like we did on the previous one. We just factored out a GCF and we made it into a quadratic equation. So now our trinomial inside the parentheses, that's an easy factor. Two numbers that multiply to make negative 10 and add to make positive 3. That's going to be x plus 5 times x minus 2. And then we still have our GCF there of x to the negative 3/2 power. Now we use the zero product property to solve. So this is going to give us x equals positive 2 for an answer. This is going to give us x equals negative 5 for an answer. And over here, this one's a little bit tricky. Okay, remember x to the negative 3/2, when we set that equal to 0, let's take a look at what this looks like. X to the negative 3/2 has a negative exponent. So let's move it downstairs because right now it's upstairs. So then that becomes 1 over x to the positive 3/2, okay? Let's change that to radical form. So that's going to be 1 over the square root of x cubed, right? When is that ever going to equal 0? It's not, because my numerator is always going to be 1. So that expression can never equal 0. So this one gives us no solution, okay? But these two give us good answers, negative 5 and positive 2. Keep in mind that a fraction is equal to 0 when its numerator is equal to 0. The numerator in this fraction is a 1. It will always be a 1. It will never be anything other than 1. So this fraction can never equal 0. That's why this monomial expression gives us no solution. Second step, sorry I forgot to fill that out here. We are going to factor out our GCF, which is what we did. And in the case of this problem, it was our lowest exponent.